Hey everybody, welcome back. Today we'll be talking about a new form of supports that I've created for some of the parts that I'm designing, and this is just to suggest one way of doing this. The reason that I like this set of supports, we'll get into more of that. So, taking a step back, a little bit of background on why I'm drawing my own supports and don't just use the software's support program is because honestly, I use KissSlicer and I haven't figured out how to use the support options yet. But as well, uh, creating my own supports allows me to choose where they should be and where they shouldn't be, versus KissSlicer I think would just go nuts and put them everywhere and possibly put supports where it'd be super difficult to get them out. So I want to make sure that I created supports in very specific places. And a little bit, so I'm using KissSlicer here. I haven't figured out the supports, and I'm using a Monoprice Mini Delta V2 3D printer, and we'll have an episode about the two different 3D printers we're using, just for benefits and that sort of stuff. But just know it's a super small printer. It seems pretty robust, and probably the biggest thing is it's super cheap, and the cartridges are super cheap for it. And so number one, that allows me to 3D print lots for super cheap, so I can really dial these parts in. But number two, it allows me to, really dial these supports in with the right, gaps between my part, as well as what the tooth pattern should be, etc. And then Abel has an Ender 3, and so this is sort of what he's designing for. A much bigger bed, so that's beneficial, and it's still pretty cheap as well. Okay, so getting back to the part, one thing that, in KissSlicer or many of these slicing programs, it would use sort of a wiggle pattern to go back and forth across these faces. I started drawing those wiggle patterns, but like on a larger face, like this underside here, the underside of this. That's a lot of wiggles. That's a lot of corner rounds. That's a lot of just hassle, pushing it back and forth. So kind of what I stumbled on was, why not extrude a block of material up to that face? And then I've added cancellation features to minimize or to reduce the amount of surface contact between the top of my support and the underside of my part. And so that just makes it just a little bit easier to remove this support off of there, as compared to if this was just a flat surface. Yeah. And so we'll get into a bit of how I created these. Again, this is working in PTC Creo. Yeah, and I'll just hop into it. Okay, so let's back the model up. And so we've got a couple overhangs. We've got one here, we've got a couple here, as well as the underside of these and the underside here. So I've decided to break these out into different sets of supports. You could tie them all together. I find that breaking off little chunks, like a bunch of little chunks versus one huge chunk, just it goes faster, as well as they just peel off a lot quicker and they support the same. So I just did it in a bunch of small pieces. But what you can see here is that I started with just an extrusion that's offset from that top face. So if we get into the actual sketch that I used, you can see that it's essentially approximating this underside face, and then I've offset it away from these sloped faces by 0.2. And what I found is that's close, but it's close enough that we're not bridging a lot, but as well it's far enough that the support won't accidentally fuse to these angled faces. Cool. So I'm just going to do just a generic block that kind of matches the profile there. And we'll get into more irregular shapes in a little bit, but okay. So I've created a block that goes up, and for the Monoprice, 0.5 seems to work well as an offset between your support and that underside face, that it allows enough non-contact that it makes those things easy to break off. So the next part that I added, and you'll remember that I had sort of the castellated features, and what this does is it breaks up that top surface just so that there's slightly less contact with that underside face. And it just makes these things easier to remove. And so it's a pattern of this first rectangular cut multiplied across that to be 6 different extrudes. So if we look at this, we'll open our first cut. You can see that it's a rectangle. I've offset it 0.5 from this edge because my bead width for the monoprice is 0.4, so I just made it 0.5 so that it's bigger than that, so that Slicer will add 1 bead of material to fill this width. And then I made it 0.3 deep so that my bead width is 0.4, my bead depth is 0.2, and so I made it 0.3 just so that it would be 2 beads, at least 2 beads, stacked on top of themselves. And I think that just increases the distance between this underside face adhering from the greater contact area, which is the bottom of this. And so it just distances the top of this from the bottom of this, just so that underside doesn't adhere to both the bottom and the top. Cool. So I do that, and then I extrude all. Extrude all is a really good technique. Use it when you can. Don't just leave it with a dimension, vaguely off in space. That's poor practice. Okay, so that's through all. I'm gonna hit OK. I know, right? So, and then this is just a pattern feature. If we want, we can delete this. Suspend these because they relate to that. Okay, and so we would have created a pattern which you select this first feature. Let's delete that. Okay, so in order to create a pattern, we would select our feature, we'd pattern this feature, and let's do 1 offset from here, and then we're going to do, so that gives us our offset distance along this face or along the top, and then, I don't know, let's say 6 of these should cover that face. Cool. And so you can see how this last one is kind of hanging off the end. Let's grab this one, and so let's change our offset to, no, let's change this to 0.8, and let's change this to 0.2. So we do that. So now you can see, okay, so let's do 0.9. Let's do 0.3. Good. And so now you can see there's this one, what isn't just hanging off the end there. Let's check this because my bead width is 0.4. Let's see how wide this is going to be. So 0.58. It's close enough to 0.4, far enough away from 0.8 that it'll just put 1 strip down there. So now you can see that we've got these castellations on the top side of this, again, to remove or to reduce the adherence of that underside face with our support, just to make it easier to get off. Cool. And so now coming down here, we've got our pattern. Insert here. I've added some corner rounds just to make it slightly easier on my 3D printer to go around those corners. I mean, you don't have to do that, but I do it just because it makes it look pretty as well. So now we get into hollowing out our support just so we're not wasting a bunch of time and material making our support because it's just going to be thrown away. And so what I've used for this feature is I've used the offset feature and I've selected loop. And so whenever you click this, there's actually 2 faces. Isn't that a movie? Okay, so there's actually 2 faces. Okay, there's 2 faces that this references. You can see how both the top and the bottom light up whenever I drag the mouse over it. So I'll click there, and then it's going to ask me which one of these do I want. And so I'll hit next, and you can see how this one's blue. And I'll hit next again, so that one's blue. So that means that we're going to choose this one. So I'll hit accept. And then I know, again, because my bead is 0.4 wide, I'll make this negative 0.5. The reason it's negative is because this arrow is pointing out. So I want to go negative to that. So that'll create an offset to the inside. Cool. So you can see I've created an offset, and what that'll do is hollow out this support by 0.5, which means it'll just be one bead of material around here, and it'll just be a column of one bead all the way to the top. Cool. And then I did the same thing for this support as well. And by adding the corner round to my supports, you can see that it makes the inside have a corner round as well. Ooh, it's nice and sexy. So, yep. So what that did was that created a shell on the walls. Now what we're doing is I've actually offset this pocket 0.7 from the bottom of those castellations. And the reason that I chose 0.7, again, the bead height is 0.2, and what that allows is at least 3 layers, possibly 4 layers of capping of this support before I start building my castellations. And even if I went, if I stuck with a flat plane like this, and it had to bridge all the way across here as it's drawing these layers, in 0.7 millimeters in those 3 or 4 layers that it has to build that cap, it would resolve probably in that 0.7 millimeters. So it'd be super messy on this first layer, but then by the time I got to the base of my castellations, it's going to be pretty flat, such that the castellations are true so that I can build the face off of that underside. And so, again, I chose 0.7. You could make it more, but it's that push and pull of building a solid foundation for your underside features and not wasting a bunch of time building supports. So I chose 0.7, and so I chose 0.7 for that cap thickness. Cool, and you can see how it stops short of there. And so again, that'll build that cap. And right now these are totally unsupported. What I've done to make this so that it's less of a mess underneath there of unsupported material, I added a 45-degree chamfer to the underside of that, just so that most of this will be supported. And what that leaves us with is an unsupported width of 1.12. That's probably fine, especially since we have a couple layers. Number one, this is just support. Number two, we have a couple of layers for it to resolve itself, so that's more than fine. You could probably make this chamfer even smaller, but I just went for 1.2. Won't cost us that much time. Yeah, and that's what we're going for. Cool. So that's these outrigger type supports for this underside feature here. Looking at the next set of supports that I created, again, this is for that whole central portion. So let's look at the sketch for this. And you can see in this instance, I actually went around and found all of these edges here and the flat edges around this profile, and then grabbed that flat edge and just offset it from there. If there had been a continuous profile around there, then I could have used my offset to just kind of put an offset from that, but like you can see that this part's offset, but this is right on it. So I drew this myself because I wanted to be able to control what was directly on the geometry and what wasn't, what had a slight amount of offset. So you can see that this generally approximates this underside features. I don't like that sneaks in from that corner, because then this material that's unsupported might droop a little, especially as it's drawing that border, the outside, the shell. It easily could droop there. So I'm going to change this to, let's go with 2. It needs to be a little bit more. That looks perfect. Cool. So now we know that that underside face will be totally supported. So let's hit go. And you can see, once again, the offset from the underside of that face is 0.5. Again, I find that's really good for being able to peel this piece off. Yeah, so it shows 0.5 again. Now we're going to add the obligatory rounds that just make the whole thing pretty and make it easy on my 3D printer, slightly easier. And then let's add castellations once again to kind of break up that top surface. And I used the same, or I used a 1mm offset between these. I don't know, 0.5 gap, 1mm between castellations seems to work pretty well. And then again, the same 0.5 width on each of these high points, just so that it's one bead of material. And then there's 15 extrudes. And with this, because this feature, because my support stops short of this inside wall, I was able to extrude the valleys from this close side of that support, all the way to the far side of that support, and I could just do one pattern all the way across here, and that's fine. So that's the support for that middle section. Then we're going to hop into shelling this out. I've already showed you how to do that. And again, the 0.7 offset for the cap of this, just to make it solid before, printing the turrets of our castle. And so you can see that, there was very little unsupported here, that even if we didn't have these chamfers, it probably would have been fine. Now we've got a lot bigger space under here and a lot bigger bridges. Two things that we could do. Let's definitely add a chamfer, because you just click an edge and it would add the chamfer to all of the stuff. But we also could choose to make a little island of support in the middle if we didn't want to put crazy big chamfers here to kind of support, loosely support, pseudo support this central section. Let's see what I actually did. And so what I did for this one was I just created pretty big chamfers, and I've left this center section open. It'll probably be fine. And as well, one thing that you could do is, you could do, nope, let's do this, details. In some CAD programs, you could do this and hit OK and do like a super big one for a couple faces. You could do a super big one for maybe 2 or 3 faces or 2 or 3 edges. Cool. And then you could come back with a smaller chamfer. Let's do one, something like this. You could come back with a smaller chamfer to kind of clean up the rest of it, and then we've got small amounts here, and then it's sort of a push and pull of that. I've decided to go with just the same size chamfer. It was easy, and this will support it well enough. Cool. Next, I've supported this, and then we're going to go through the same 2 things. Now you can see I added beautiful corner rounds, castellated the top of this, added rounds, and then hollowed out the middle. Cool. Cool. And then I supported that. Next, I ended up supporting these lateral pegs on these pieces, and you can see that I went with a slightly different support structure. Yep, so you can see I've got some bum references, so I'm fixing these references. Okay, and so what I went with here was just a U-shaped bit of support. I could have gone for just a strip and a strip, but I went with a U-shape just so that it's the same, just so that it's one continuous pathway. Adding this little bit of support, bridging these 2 things together isn't much. It isn't much time, it isn't much extra material, but as well, it'll support the end of this peg. And as well, I made these supports 1 millimeter wide. And the reason that I went with 1 millimeter, again, my bead width is 0.4. So 1 is bigger than 0.8, but smaller than 1.2. So it'll approximate this as 2 beads worth of, it'll be 2 beads worth of 3D printing. And so it'd be an up bead, a down bead, an up bead, across, down, up, and then connect that. And so that'll just make a much more robust support for this. What I found is because the peg is so small relative to the bead size, just the resolution's garbage on it, and it just doesn't come out clean. And so by creating such a wide support, I'm hoping that it just creates a better peg. So if we do this, and then as well, my offset here is 0.3. I've chosen a closer offset just so that I can get better resolution on this peg. If this had 0.5, then that bottom layer would droop a bit more. With 0.3, it's going to droop less. Yes, that'll make the adherence of my support to that underside face greater, but this is a super small support. So it'll peel off easily anyway, so calling out 0.3 is okay for this specific application. If we used 0.3 for these larger supports, I think they'd be really, really difficult to remove. And so, yeah, that's kind of why I can get away with 0.3 on these lateral supports. Cool. So that's supporting this, this part. So if we save this, and then I'm going to go to A1 reorient. And so this is that same part. It's just reoriented in a way that just pops right into KISSlicer. And the benefit of that is with all these corner rounds, it just makes it time consuming to reorient. And so when I make a lot of changes back to back and I assess them in KISSlicer, it just cuts down on the time to reorient. So, okay, so we'll hit that, and I've set up a quick key in Creo to export things that manufacturers usually use. So the 3 things that I export with that map key is an STP, an STL, and a parasolid. The parasolids and step files usually go to vendors. The STLs are what is what they use for 3D printing. I use it here at the house. We use it at the office. Yeah, so by having a quick key, it just spits out those 3 files, and it just, yeah. Then I've got all the files I need for creating 3D printed parts. So this is an A1 reorient. Cool, and you can see that we pulled it into KISSlicer. We can see our supports in there with the little castellated tops. All our little supports, great. So if we slice this, go to our paths, and you can see that this is the top part. And so what we can see is now, because that turned pink, that means that it's unsupported. Thankfully, we know that there's 1 layer, 2 layers, 3 layers of gap before our castellations start. And you can see that these are just individual strips of material that will make the top of that support. And we know that there's now 1, 2, 3 layers of air gap between the underside face of this and the top side of our support. I know, because I've printed a bunch with this printer, that that gap works pretty well for peeling these, for peeling the supports off, but also it's close enough that the underside of this face won't be all just gross with sagging material. Cool.
Hey, John.
And so as we step through the part, go.
Can you stop your camera and restart it? It's like super pixelated.
Oh yeah. Yep. Yeah.
Thank you.
And we're back. Is that better? Everybody, no complaining? Yep, can't hear anybody complaining. Cool, okay, so, and then this gets into our support, and you can see that if we go 1 layer, so our support starts. That's one layer of support. That's two layers of support. And now we get into the main meat of our support. And you can see that that's that cap that we did. And then that's the top of our cap, 2, 3, 4. So that our cap will be 4. We chose the cap thickness of 0.7. What that's resulting in KISSlicer is 4 layers of cap. And so you can see how the middle part of our cap isn't supported, but 4 layers of cap will be enough that if any of this droops, it'll catch up by the time we get to the top of our cap. Cool. And then you can see as we get deeper down, that's our chamfers bleeding out, and it goes all the way down to 2 and now 1. And so it's just 1 through the rest of the part. And so what that creates are just super thin supports that in PLA are strong enough to support the part, but they're strong enough to support the part, but easy enough to tear off that they're great. And then as well, sometimes on the printer, the first few layers of the support are really, really muddy and just kind of all over the place. These supports are tall enough that they kind of resolve themselves. If it's muddy at the base, it eventually resolves itself by the time we got to our cap. Yep. So once it starts into the cap, it's usually fine. You can see our lateral supports here, and then they get hollow. Cool. And then as we look at where the pegs are, the pegs finish there, and then you can see the U-shaped supports that we have there. It's the 2 layers of material. It's 2 layers of material that makes a pretty robust support, and it gives us plenty of support for the underside of our peg. Cool. So that's supports, or that's these types of broad supports for large underside faces. I want to talk a little bit about how to do it around irregular geometry. Let's go to this. So you can see this is another component for something that I'm designing, and what it has is, you can see it has 2 different levels of support. Number 2, it has these upward facing faces. And so those are especially hard to support because those underside faces, it's a shallow angle. You know, it's way less than the 45 degrees, but as well, it's a super shallow angle, but as well, it's down facing. So it's just going to look really crappy on these FDM printers with the 0.2 layer thickness. But you know what? These supports help make that as good as it's going to be. And then as well, you know, for some of these things, for some of these grooves, if you go across, it takes us into the middle body of the actual part. So if we get down here, yep. And so you can see, yep, and that's more supports for those. You can see that this is the part, and I'm going to build in my printer up from the bed, which is on this face. And so these faces are pretty big and need to be supported. So I've created supports like these. And so to create the castellations, I had to do 3 different patterns. I did a pattern down the hill, then a pattern across until I got to the main body of the part. And then I did a 3rd pattern for the middle, for what intersects the main body of the part. And then I just did these up to these inside curved surfaces. And then I had to create castellations on this side that were extruded up to this a similar curved face. Cool. So that's these broad supports, as we can see, or as I've started using for my 3D printed parts. And then using just a single, well, these are These are 1 millimeter width. Good. That's resolved. So these are 1 millimeter width supports, so it would actually be a racetrack in this pattern. And you can see that it goes in the top and bottom to be able to support these tabs that are overhanging. So let's hit OK, and you can see that I used the 0.3 for this. These are pretty easy supports to remove, and so the 0.3 gap is just enough that we can, that the underside of these faces will be pretty clean, and the support will be easy to get off. So, great. That's a new format of supporting that I've started using because it's pretty quick to create some pretty rough supports. So, good. I think this is good. If you'd cut, then we can, I'll give you a call in a little bit. I need to take a quick break. Is that cool?
Yeah, can I ask a couple of quick questions for clarification?
Yeah.
I guess?
Yep.
We'll try and make it really quick, but so you have tested these and they break off cleanly, yes?
Correct. Yep.
Okay, so like pretty minimal like sanding or filing afterwards?
Exactly. Yep.
And then the next question I was,
And a principle to that thought that we'll get into more when it comes into designing for manufacturability, but the 3D printer that I have is super crappy, and really the finish isn't great on these parts at all. But what's great about, you know, designing for manufacturability is all about knowing the tool that you're working with, and the finish might be crappy on these parts, but at least it's consistent such that I can always choose that 0.5 millimeter offset, and I know that, yeah, that'll be an awful surface finish, but at least it'll be consistently at that same height, that this support works every single time in the same pretty consistent way. Cool?
Yep.
Yep.
Yeah, and then I guess I wanted to go over the gap between the part geometry itself and then the start of the castellations, which we discovered before is a real word. So I did not know that was a real word. I just thought Jonathan made something up. But
Right.
Is a real word for making something look like the top of a castle. So anyway, yeah, so since he's already tested this, we know that you said it's a 0.3 gap between the top of the castellations and the part itself.
So on broad ones, it's I guess I chose 0.3 for this. There's another part that mates between in the gap between that face and the underside face. And so I guess I chose 0.3 for these, and it still removes pretty easily. Yep.
Okay. Yeah, and
yep.
I guess, you know, intuition would tell you that you need to extrude those all the way up to the part.
Sure.
In practice, we talked about how there might be a little bit of actual drooping of the material or mismatch between like where the center of the nozzle is and where the outer boundary of the material actually turns out to be that closes that gap. And you found that amount of gap is appropriate in that it's not too difficult to remove because you don't want it to be too intimately integrated in between the two parts, or else it'll just kind of rip some material off that you don't want it to. But then it also actually does support, because a larger gap would mean that you get more drooping that you don't want when you're printing the part, correct?
Yep. And I think to the point of it drooping, you know, as it's extruding, if the support was at that next level such that it was printing directly on top of it, the material would still be hot. Therefore, it would bond very, very tightly with the support that's, you know, at that next layer lower.
Yep.
By giving it just a little bit of gap, 1 layer, 2 layer, 3 layers, what that allows is for that bead to cool a little bit before it contacts the support. And so it still does contact that support because it's still solidifying, but because it's solidified a little bit, because it's had just slightly longer to be in the air, Yeah, because it's had slightly longer to be in the air, it's solidified slightly more, so it just sticks a lot less and more just rests on that surface, therefore making it a lot easier to peel off. And like Abel said, especially with an FDM where it's printing like very discrete layers, if your support is too close to it, as you peel your support off, it'll just rip off that underside layer, or rip off chunks of that underside layer, which affects the consistency of that underside surface, you know, and it affects the consistency of what the printer can print. And so, again, what we're looking for is consistency. That if it's, you know, it could be crappy, but at least you want it the same consistently crappy, because then you can work in those parameters.
Yep, yep. And that's also something we talked about, you know, wanting to at least come up with something that's precise. It may not be accurate, but it's precise.
Sure.
You can work with that. You can make it better.
100%. Yep. And then, you know, and this gets into the manufacturability stuff. Once you know, it almost doesn't matter what the dimensions are on here. You just need to know, if I made this part and it's too tight fitting on there, then I measure this gap. You know, for example, I measure the gap between here and here. And it doesn't matter if it's 12 millimeters here, and after, when it comes off the printer, it's only 5. All I care about is I measure the mating part and I measure this gap, and whatever that difference is between those two, I just either add or subtract that to this gap, you know? And so it could be if this gap was 12 millimeters and it needed to shift 4, it doesn't matter that this now is 16, as long as what the part prints as is that 5 millimeters you were looking. Yep.
Cool. All right.
Cool.
So I think
Yeah.